A few very important reactions of carboxylic acids that are frequently tested in the A2 syllabus. Okay, but before we proceed to the reactions of carboxylic acids, there are some important reactions that we need to do before proceeding there. Okay, these reactions are of the three compounds, the phenol, ethanol, and ethanoic acid. And the reactions are with first reaction is with sodium metal. This is sodium metal, and with sodium metal, we know that phenol is acidic. We know that ethanol is also acidic, and ethanoic acid is also acidic. They'll give a positive test with sodium metal because sodium metal is highly reactive. It will react with phenol to give sodium phenoxide. This organic product is important and it has been frequently asked in the past papers. Then with ethanol, the product that we have is sodium ethoxide. Okay, this is sodium ethoxide, not sodium ethanoate. This is sodium ethoxide. People often confuse this with sodium ethanoate. Sodium ethanoate is the salt of ethanoic acid, not the salt of ethanol. Okay, sodium ethoxide is a salt of ethanol. And then the third salt that we get is sodium ethanoate with ethanoic acid. Okay, then the next reagent that the reaction undergoes is with sodium hydroxide. Sodium hydroxide is an alkali, and then the phenol gives a positive result with the alkalis because phenol is acidic, and the product is the same. It's sodium phenoxide salt as the major organic product. Sodium hydroxide, being an alkali, has no reaction with ethanol, and no alcohol has any reaction with alkalis. Okay, so alkalis and ethanols and alcohols do not react. Alkalis have no reaction with alcohols. Okay, this is a very important point. Do remember it. And then again, alkali will react with the carboxylic acid and give again sodium ethanoate as the product. Okay, now the third and the final and the very important reagent is sodium carbonate. Sodium carbonate has no reaction with phenol, nor it has any reaction with ethanol. Sodium carbonate only reacts with ethanoic acid. So basically, sodium carbonate then finally gives the same salt, sodium ethanoate, and from this we can deduce that sodium carbonate is the best test for carboxylic acids because it has no reaction even with phenols. All the phenols are more acidic than alcohols, but they have no reaction with phenols, no reaction with alcohols, and they give a positive reaction with carboxylic acids only. And then the organic product is the same, sodium ethanoate. Okay, now let's talk about a few reactions of a few important carboxylic acids. And these important carboxylic acids are methanoic acid, the first acid that we have in our carboxylic acid family. This carboxylic acid, if we look at the blue outline, it's the carboxyl group, the COOH group. But if we look at the red outline over here, this red outline represents an aldehyde group. Aldehyde is basically a CHO group, a carbon double bonded O with a terminal hydrogen group. All aldehydes are reducing agents. So basically remember this important point that aldehydes are reducing agent. And why are they reducing agent? Because they have this hydrogen over here. They have a terminal hydrogen attached to the carbon atom. Terminal hydrogen atom attached to the carbon atom, which they can donate, and reducing agents can donate hydrogen atoms. Okay, now the first reaction that we have over here is oxidation. Oxidation of the carboxylic acid or oxidation of methanoic acid. Okay, oxidizing agent used over here is KMnO4 acidified and heated. Okay, this O represents the oxygen from the oxidizing agent. The carboxylic acid, the methanoic acid, gets oxidized to carbon dioxide and water. The equation is not balanced and I'm not balancing it because the balancing isn't that important. Just learn the final product, and or you, if you want, you may balance it, but it's not that important. Then since this is an aldehyde, it will give a positive result with all the tests for aldehydes. The test for aldehydes that we did in AS were Tollens reagent test, Fehring solution test. They both in the Tollens reagent test were, if we recall AS, silver mirror was formed if aldehyde was present. Silver mirror test. This was also called a silver mirror test, and the reagent used in this Tollens reagent that was used was silver diamine silver 1 with a positive charge. This was the cation present in the Tollens reagent that was used as a test for aldehydes, and this would then get converted to silver element, silver mirror would have formed. And then the second reagent that is used is that gives a positive test is the Fehring solution test, and Fehring solution contains copper 2 plus ions and OH negative ions. They and the final product, the positive sign of this presence of aldehydes is indicated by the production of brick red PPT of copper 1 oxide. Copper 1 oxide is a brick red PPT which is formed when aldehydes are present in the Fehring solution test. And then I've made a few equations over here. So then again, methanoic acid combines with Tollens reagent to give carbon dioxide and water. Again, carbon dioxide and water. In oxidation, the products were carbon dioxide and water. Over here, this is basically an oxidation reaction. Oxidation reaction, therefore, it gives carbon dioxide and water again. And then test Felling's test also gives a brick red PPT. Felling's test does give a brick red PPT. Felling solution test, and in Fehling solution tests, a brick red PPT is formed, and this is also an oxidation reaction, or you may also call it a redox reaction, in which the methanoic acid gets oxidized to carbon dioxide and water again. Now, the next important acid that we are going to talk about is the ethane dioic acid, carbon double bonded oxygen, ethane meaning two carbons, and then dioic acid meaning two carboxylic acid groups. So this is our ethane dioic acid, which is also referred to as the oxalic acid. Okay, now oxalic acid, again, the reaction that we had with methanoic acid, oxidation with KMnO4 acidified and heat, the products are the same. We get carbon dioxide and water. Okay, so carbon dioxide and water, the products are the same, and this is the oxidation reaction with uh, this is the oxidation reaction of oxalic acid with our oxidizing agent KMnO4. Now, this is the overall equation. But now, if we split these the equations into half equations, so what we get is that the manganate ion, the MnO4 negative, this manganate ion is basically, it has been reduced itself to Mn2 plus ion. Mn2 plus ion. The manganese in manganate ion has a charge of plus 7, but it has been excuse me. Okay, manganese has a charge of plus 7 in the manganate ion, and this plus 7 charge has been reduced to plus 2 charge. So basically, this oxidizing agent has been reduced, and the carbon in the oxalic acid, the carbon in the ethane dioic acid has been changed to carbon dioxide. In the carbon dioxide, carbon has a charge of plus 4, whereas in the oxalic acid, the charge on carbon, let's assume it to be x, so 2x plus 4 into minus 2. Minus 2, because oxygen has a valency of minus 2, is equal to minus 2. Minus 2 again, because the overall charge of this ion is negative 2. Let's calculate the value of x, and it becomes 8 minus 2, 6, and 6 upon 2 is plus 3. So the carbon over here in the oxalic acid has a charge of plus 3. So this plus 3 carbon has been oxidized to plus 4, because increase in oxidation number is oxidation. Increase in oxidation number is oxidation, and so the carbon atom has been oxidized and the manganese itself has been reduced, so the oxidizing agent, it does get reduced. Okay, now there are redox calculations on the basis of these two equations, and we are going to talk about the redox calculations in the next video. Thank you so much.